Welcome to this video about forces of particles, and in the previous video we talked about different forces acting on particles, giving a certain terminal velocity of a particle. And in this video I would like to talk about one of the tasks I gave you at the end. So I would like to show you the solution of the question about the settling of lithium carbonate particles. So therefore, I will just shortly repeat the content about the lithium production, and then we will again ask us the question which forces act on particles, and then we will calculate the settling velocity of these particles. So basically we learned about these brines where lithium carbonate is precipitated. So first we have to purify the brines, and then we get this purified brine, and then we have here the precipitation of lithium carbonate under given conditions, and then it goes into different separation devices. And one separation device of interest is this thickening tank, and in the thickening tank the precipitated particles settle down to enrich the amount of particles in the liquid and then go into the cyclone here and the filter. Okay, so if we take a look, this is the picture of the thickening tank, and the question from the previous video, or one of the questions, was calculate the terminal settling velocity of a 20 micron sized lithium carbonate particle in water. What time does it need to settle 2 meters? So we have particles here, they settle down, and the question is, if one of them is 20 micron, what is their velocity? If we look at the forces, and I just go fast through it because we already made it step by step, we introduced 3 different forces, and these 3 different forces are the gravity pulling down, the buoyancy acting against gravity, and the drag force acting against the movement of the particle. And the drag force is given as a specific equation, and this is the called Stokes regime. And in the Stokes regime we assume laminar flow, so the particles settle very slow, that's the assumption. But if you think about a thickening tank, slow settling makes probably sense. And from these 3 equations we could get from a force balance by balancing, right, gravity equals buoyancy plus drag force. Then we put in the equation, we rearrange a little bit, and then we get this final equation of the terminal settling velocity. So no acceleration, steady state, laminar flow, and then this is the equation. And if we take a look at our question, so the size, we need certain numbers. The size we know, this is the diameter, and we talk about 20 micron. G is 9.18. So there are 3 variables here which are missing, and this is the density of the particle, the density of the fluid, water, and the viscosity, in this case the dynamic viscosity of water. So you can go to Wikipedia or whatever you want to look up these numbers, and then you will get a a density of the particle around 2.11 gram per cubic centimeter, and this is for lithium, or lithium carbonate, sorry. Lithium of course has a different density. And for water it's, here's a mistake, I'm sorry for this. This is the density of water, so think about an F. Density of the fluid, 1 gram per cubic centimeter. The viscosity, dynamic viscosity of water is 1 millipascal second. And now we have everything which we can put into the equation. So this is what you see here, 2100 kilogram per cubic meter. Why 2100? It's this time 1000, and it's simplified, so I kicked out 1. But at the end this will not make a large difference. And 1 is 1000, and then times 9.81. And here, if we think about 20 microns in meters, because the most challenging part of this equation is to put everything into the correct numbers, and especially in the correct units. So 20 microns is 10 to the power multiplied 10 to the power minus 5 meters, and this has to be squared, divided by 18, and then it's 1 and now multiply 10 to the power minus 3, because this is not meter, this is millipascal. If you make the units here, you will see this cannot be meter, this has to be milli. So if you are unsure about this, always check the numbers. And if you put all of this into a calculator, you will end up with this number. And this is 2.3 multiplied by 10 to the power minus 4 meter per second. So this is really, 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 really slow settling. But it makes sense, right? Because 20 micron are very small particles. And if you look at sedimentation in water, you know that these small dirt particles really take time to settle down. And this means that the settling time for 2 meters is more than 8,000 seconds, or roughly 2.5 hours. So if we precipitate lithium carbonate particles in the size of 20 microns, and we want them to travel 2 meters in a thickening tank, by settling, it will take 2.5 hours for them to settle. While you have to consider this is a strong simplification what we have here, right? It's a very simple model. We neglect a lot of things. We have a very simple force balance. And for example, we're neglecting the presence of other particles, right? If you look at my picture, there are no other particles. But normally, especially at the bottom, there are a lot of other particles and they interacting with each other. And this means it takes even more time for them to settle. Okay. So this is already the solution, and I hope I could repeat quite fast the insight into the lithium production, and you know why this question is important for lithium, or especially lithium carbonate production, which forces act on the particles, and how do we calculate the settling velocity from this. With this, we are already finished with this video, and thank you for watching.